chain rule with other rules. Okay, and those other rules, so the other rules could be product rule, quotient rule, or it could be the chain rule again. And so I think those are the three things. So chain rule with other rules. With other rules, so that's what we're going to do today. So we know all the notes. We know the product rule, quotient rule, the chain rule. We might even use the chain rule twice. Okay, so we'll go right to examples. Our goal is to get through 6, so we'll see how we do. So the directions are to differentiate. You know, sometimes I distinguish like notes versus then examples, but like I said, we have all the notes. We just got to practice it, put it together in a new combination. Okay. All right, so we'll differentiate, find the derivative. And what does the derivative find us? Slope. Okay, remember that's our goal now. Can we take any equation, find the derivative, so someone can go find slope? All right. I don't know why they did capital N of x equals, and then it's 6x minus 7 in parentheses to the 4th times 8x squared plus 9 squared. Problem starts big, the answer is big, and that's okay. All right, so don't panic. It's just that answer is going to find a slope, so whatever it takes. Okay, so remember chain rule as well as other rules. So we kind of have to look at it. What do we see here? We've got a quantity, so there's our chain rule, but times another quantity. So the first thing we're actually going to do is the product rule. Okay. So we want to do the product rule, and that's kind of the only thing we do, but as we go through the product rule, so what is going to be our f of x? The first thing that we're multiplying, right? And kind of notice that it's a quantity. So take the 4 with that whole quantity, that's important. 6x minus 7 to the 4th power. So now we have to think about when we take its derivative. We have to do the quantity. So the chain rule with other rules, so within the product rule, we've got to use the chain rule when we find this guy's derivative. So our Q is 6x minus 7. Its derivative is not too bad. Its derivative is 6. And then remember, we have to take the derivative with Q in there. So this is going to become Q to the 4th, and then take it times the derivative of Q. So we're going to replace this with our Q, take its derivative. So roll it down, subtract 1, but then we have to take it times the derivative of Q, which is the 6. And then we still have to replace Q back. So it's 4, and then 6x minus 7, don't forget to the 3rd, and then times 6. So we got to take it one more step further. We wouldn't have to, but we might as well multiply these two. 24, 6x minus 7 to the 3rd. Now it's up to you. If you feel like you got to write that, write it. That's no big deal. If you can see that you can just roll this down, let me even just do it on a different piece of paper and then we'll come back. So let's do 6x minus 7 to the 4th. If you can see this and just say, hey, I'm going to do 6x minus 7 to the 3rd, but then because I perform that on a quantity, I have to take it times the quantity and do 6, that's awesome. In fact, it's quicker and it's going to be more efficient, right? Because then you don't have to write all that stuff down. And when we get to the chain rule and the chain rule, this really helps, okay? So go for that. Now I would still multiply these two together, okay? But if you can do like, remember, if you do the derivative on a quantity, that's fine. You just have to take it times the derivative of the quantity. Okay, so we did the derivative on a quantity, so then we have to take it times the derivative of the quantity. Should we try that with G? Okay, so let's go back to our list. I'll slide it up. Well, let's see. Let's go right there. Okay. So G of X, what is G of X? The second thing that we're multiplying, the second factor. So 8x squared plus 9, and then that quantity squared. Now, should we try the shortcut? Roll it down, subtract 1, but you're performing that on a quantity. But we're still going to do that. We're still going to roll it down, subtract 1. But if I do that on a quantity, I have to take it times the derivative of the quantity. And so what would that be? What's the derivative of what's inside? Maybe a little bit harder. 16x, roll it down, subtract 1. Okay, good. 16x, and the 9 goes away. And then I would still multiply these two together, and I would still do 32x. Make sure that x comes with, and then 8x squared plus 9. What do we think? Doable? We'll maybe keep doing it that way today, and maybe you'll get then the hang of it. Okay. Okay, now we still got to go to the product rule. All right, are we ready? First times the derivative of the second plus the second times the derivative of the first. Plugging in isn't too bad. Let's see, can I go up a little bit? Yeah. So the first is 6x minus 7 to the fourth. Its derivative, just take your time, is all the way down here, 32x, 8x squared plus 9. This plus, just so, I'll do it in a different color just so you can see where we're at. This green is this guy here. And then G, 8x squared plus 9 squared. And then times the derivative of the first, follow it all the way down, 24, 6x minus 7 to the third. That answer isn't bad. If you can get there, we're in good shape. But we can do a little simplifying. Can we slow down? Are we okay with, I just took the time to read the chart, plug in the 4 things. Now, notice, and maybe that green's kind of important, you really only have, this is one term. All of that is multiplication. And this is another term. Is there something that they both have in common? Is there something that you could take out? This has 6x minus 7. This has 4 of them. This has 3 of them. So you always take out the smaller exponent. So we're going to take out 6x minus 7 to the third. These two groups are very important that you see that. There's really only one plus sign. So you can really, you have those two groups that you can take stuff out of. What else? 8x squared plus 9. Here I have 1. Here I have 2. So we're going to take out 1. Always take out the smaller amount. And we can even do numbers. 32. You can, whether you include the x or not, but we're really just doing the numbers. 32 and 24. What's the largest number that goes into both of those guys? 8. Yeah, you can take out an 8. I think we can see that there. Okay, and then we go through and write down what's left over. Just make sure you do one group at a time. So we're going to cover this group up completely. I took out 3 of these, so I have 1 left over. 32, so I took out an 8, so I still have a 4. And I did absolutely nothing with the x, so the x stays. And then I only had one, so I took one out. Then comes the plus. Maybe I'll still keep it in green. And then you do it all over again. I don't know why people want to push these together. You do it once, and then you do it again. Now you cover up this. What's left after I take this out? So now I'm only looking at, and I'll do it in red, I'm only looking now at this red one. I don't even care about this one. You have to do it twice. Okay. So this had 2, I only took out 1, so I'm left with 8x squared plus 9. What else? A 3, but I took all 3 out. But the 24, I only took out an 8, so I'm left with a 3. Maybe we can make those brackets. Okay. All right, so now we're in pretty good shape. We want to, oops, can we see it okay? Okay, now let's distribute here. We're going to distribute, we'll go back to black, we'll distribute here, distribute the 3, and then collect like terms. Okay, so this all stays. Let's maybe just do this so we can see this. So 4x times 6x is what? 24x squared minus 28x, then plus 24x squared, and then plus 27. Okay. All right, and then I think we're ready to go. The only thing is, yeah, they're pretty big. Okay, so the only thing we can put together is these guys. So here we go. Final answer, derivative is 8, that's coming from here, 6x minus 7 cubed, 8x squared plus 9, and then our last one, we can put these together, so 48x squared minus 28x plus 27. That'll find us what? Slope, okay, on that original graph. So keep in mind, I mean, let's see, can you see? Okay, so this is one step. This will be the majority of the points, but I probably will tag on a point, probably 2 points to see if you can simplify. Okay. But as long as you attempt, you'll get 1 point, and then success would be the other point. At the end of the day, could someone use this to find the slope? Yes, right? It's kind of like 2/4 versus 1/2. Okay, we like to simplify better, but at the end of the day, if you can get here, this would be an accurate equation to find the slope. Now, the other two simplify a lot more. You could argue, I don't know how much more simplified this actually is, but these next two will actually simplify definitely more. Okay. All right, so are we ready? This one isn't too bad. Let's try it. All right, so they did S of t. Now let's see, where are we at? Okay. All right, so parenthesis 3t, this is a fraction, so 3t plus 4, and then over 6t minus 7. So this fraction to the 3rd power. Oh, can't see. 3t plus 4 on the numerator, 6t minus 7 denominator, and the whole thing cubed. Does anyone want to take a first step? What do we do first? What is that? Yes. Well, we are going to use a chain rule. But what are we going to, so what's the first step that we're going to do? Yeah, it's kind of, it's actually going to kind of be the same thing. We're going to do the quotient rule because we have to do the chain rule. Does that maybe make some sense? The very first thing we're going to do, take a look at what's the outermost. The outermost is simply, we're going to do the power rule. We're going to roll it down subtract 1. The outermost thing, we're going to roll it down, and then we're going to have all this. Roll it down, subtract 1. But what did we perform that on? We performed it on a quantity, so now we have to do the derivative of the quantity. And how are we going to take the derivative of that fraction? Quotient rule. All right, so we are doing the quotient rule because of the chain rule. Does that make sense? Because we have a quantity that's a quotient and we have to take the derivative of the quantity, that's why we're doing that quotient rule. All right, so let's list it. Now be careful, what is f of x? F of x is the numerator. And then what is its derivative? And be careful, like on the homework, if they use t, make sure that you have to type t in. It's derivative, oh, actually, this should say t then too. I have to get used to t. It'll be 3, right? Just 3. All right. G of t is the denominator, 6t minus 7, and its derivative is 6. Beautiful. Good. Okay, and we did all that to kind of fill in here. We could either go back up here, or we're filling in this spot right here. Remember, g is on the corner, so we have got to do g derivative of f minus f derivative of g all over g squared. Okay, so we're doing okay. All right, so let's slide this up. You guys don't have to, right? All right, so let's bring this down. Let's bring in the 3. Can we see that? Okay, yeah, that's all right. Let's bring in the 3. This is kind of, and you can do this whenever, and you can kind of go back and forth. You may leave it, you may not. Another way to write this, we can write this as 3t plus 4 squared, and then we can put it over 6t minus 7 squared. And I did that because I'm going to have a whole nother fraction. And if you're a step ahead, we can always split it up later. Okay? And if at some point you're like, nope, I want to put it back together, you can do that too. But since I have more fraction here, I thought maybe I should split it up. Okay, so now let's go at it. G of t, now we just read this, right? G of t is 6t minus 7. The derivative is 3 minus f of t was 3t plus 4, and its derivative is, or the derivative of g is 6. And then we have to put it all over g squared, 6t minus 6. That's kind of nice that the bottoms are the same, but because we're multiplying, it doesn't matter. They don't have to be the same. Okay, so don't think like a common denominator because we're not doing anything with addition. Again, that answer isn't bad, but we can do a lot of simplifying with this one. Okay, so let's take a look. But really, we have done it. We rolled it down, subtract 1, and then we took the derivative of what's inside. So we rolled it down, subtracted 1, took the derivative of what's inside. That is really the derivative. Now it's just a matter, can we do some simplifying? So this isn't too bad. We can distribute the 3. Just be careful here. You have to distribute the 6, but what else do you have to distribute? The negative. Remember, for quotient rule, it has that extra negative. What you could do is you could put this 6 first and then just distribute the negative 6 together. Or if you kind of want to rewrite it up here, instead of scribbling out, you could write a negative 6 up above if you wanted. See that? That's pretty important. Okay. Let's see. Okay, so that gives, okay, so now let's go ahead and do that, right? So that gives us 18t minus 21, all right? And then if we move that, make sure we take the negative with, so negative 18t and then minus 24. 6t minus 7 squared. This is in parentheses. We could probably change it to just parentheses now. And this one just happens. It won't always be the case, but these guys drop out. And we actually just have negative 21 and negative 24 on the top. So that gives us actually negative 45. Okay, so let's see, what do we have here? We've got the 3, and then we've got, this is a 3t plus 4 squared. Let's see, can we see this? Yeah. Okay, over 6t minus 7 squared. All right, and then what's left here? We can even now just kind of separate this. We've got the negative 45, and then we've got the 6t minus 7 squared. And then out of that, we can multiply the negative 45 and the negative 3. It takes us what, to negative 135? So negative 135. Now this might be, and then we still have the 3t plus 4 squared. And on the bottom, they don't have to be the same, but they are both 6t minus 7s. So to multiply those, you simply add the exponents. So we're going to put those together as 6t minus 7 to the 4th. So remember, so on there, this answer is not wrong, but do we see how this did significantly reduce? But this, if you plugged your number in wherever there was a t, that would give you the slope. Okay. This is more the algebra. Okay, so at least try it, give it a try, but you will definitely get the, a big chunk of points there because you at least found the derivative. Let's see. All right, let's do another one. Are we doing okay? We got one more, then we got some trade. We haven't done chain rule and chain rule, so let's see how we're doing. Okay, let's bring this back down. This one's kind of long. All right, let's try it. F of x equals, now compare that. Okay, so let's write it and then we'll compare it to our last one. And you probably can't see that. Okay. All right, so it's another fraction. So f of x, numerator's x minus 1 cubed, and then the bottom is x squared plus x to the 5th. So the last problem, the whole fraction was together and you had that one exponent on the outside. So you performed the power rule right away. What rule are we going to do first here? Yeah, do you see how the numerator and denominator are totally separate? So we have to do the quotient rule. Okay, so we're doing the quotient rule right away. So it's going to be f of x, and remember again, that just specifies the numerator. Okay, so the numerator is x minus 1 to the 3rd. Okay, so do we see how, because that numerator and denominator are totally separate, we perform the quotient rule right away. Now, here's where the chain rule comes in. What is this guy's derivative? You can do q if you like. Otherwise, can we roll it down, subtract 1, but because we did that on a quantity and not just x, we have to take it times its derivative. But you get lucky, so this isn't a good test question because what is its derivative? 1. Yeah, and that's okay, that's always nice, but you always have to make sure, you might even want to rewrite it in your notes just so that you remember that you did take the derivative, it just happened to be 1. All right, and then g of x is the denominator, x squared plus x to the 5th. And then what is its derivative? Now here we go. Can we do the chain rule without the q's? Roll it down, subtract 1. Don't forget to put the 4 there. But now you've still, because you perform that on a quantity and not just a simple x, you have to take the derivative of what's inside. This one's a little bit longer, right? This one is 2x and plus 1, right? So this one isn't too bad, but the x does go to a 1. So you actually have another value there. You have 2 terms in that. Okay, so do we see how we did the chain rule right here? We did it without the q's, but it does save some time if you can see that. And how do I know? To remember, as soon as there's a parenthesis, if I perform a derivative on a parenthesis, I'm taking the derivative of what's in the parenthesis. All right, then we're good to go. Then now we're ready. So that was, we kind of already did the quotient rule and the chain rule. So now we're ready to go. G's on the corners. It's always the derivative minus, don't forget that. F of x, derivative of g. Remember the g's are always different. And then we just have to talk about this a little bit. G of x, and we have to square that. Okay, so now it's just a matter of plugging in, and our fun word that we like today is the simplify, right? That'll get us. Okay, so we kind of have 2 new things, right? We've got this chain rule and stuff, and then we also have to think about simplify. All right, so let's just plug it in. G of x is x squared plus x to the 5th. The derivative, oh wait, did I do that right? Yeah, okay, we're right. The derivative is the 3x minus 1 squared minus, and then f is x minus 1 to the 3rd. And then just take your time with the derivative. We got the 5, we got an x squared plus x to the 4th, and a 2x plus 4. Okay. Now, what is it all over? G of x squared, well, what is g of x? X squared plus x to the 5th, and then I still have to square that. So don't forget that when there's an exponent there. But it's not too bad. What do I do when I have 2 exponents? Multiply those. Okay, so it's going to be x to the 10th. Now, the good news is when you're simplifying, at least not right now, don't multiply all this out. Well, eventually, we're going to do some multiplying. But what do we do first? Before we multiply, a famous F word, factor. Okay, what can we factor? What do these 2, there's that minus sign, what do those 2 have in common? Let's see, not a, yeah, what do they have? X minus 1 squared, beautiful. Anything else? Yeah, and they do have one other thing, don't they? They have an x squared plus x to the 4th. Always take the smaller exponent. And I think that's it. All right, so let's go through what's left over. And if not, we can always backtrack. But this guy's gone. 4 of these are gone. So we have 1 left over. And then we still have the 3. That's not too bad. Minus, don't forget that's going to be always causes a little bit of trouble. We can put the number first if we want the 5. That might be a good idea because now it's by the minus. So that might be a good idea. All 4 of these guys are gone, but unfortunately we have 1 of these left over. And we've got this guy, 2x plus 1. And then all over x squared plus x, but we said we could change that to the 10th, right? Am I, okay, let's see. Now look at this, we're gonna clean all this up, but we've already got multiplication. Remember, that's why we like factoring, multiplying. We can cancel 4 of these guys with 4 of these guys. That's kind of cool, huh? So, let's see, let's slide it up. Slide this up. We'll see that. Okay. All right, so let's read, what do we have? We still got this guy, he's hanging around, x minus 1 squared. This guy's totally gone. And on the bottom, we now only have x squared plus x to the 6th. 4 on top, cancel with 4 on the bottom. Now it's just a matter of cleaning this up. This first one isn't too bad. We'll distribute the 3. And so we have 3x squared plus 3x. This guy's going to take a little bit of time. Maybe we can sneak it up here. Can we FOIL first? This gives us 2x squared. Now, outer gives us x, and inner gives us negative 2x. So overall, that would be a negative x. Or should we just write it? Let's write it. X. This will give us negative 2x. And then last, just watch your signs, gives you negative 1. We could combine like terms, but notice we're actually putting it with this stuff. Remember, that came from here. So we could even just leave it. So we could even just leave it. Let's distribute the negative 5. So we got negative 10x squared minus 5x plus 10x and then plus 5. Right now, are you thinking your algebra teacher? If this makes sense. All right, and then we're in good shape. Let's bring it down. We got x minus 1 squared. We've got x squared plus x, all that to the 6th. And then I think we just have to clean up this guy. So 3 minus 10, let's put the x squareds together. So that gives us negative 7x squared. Okay, we should be okay. We got, okay, so we got 3 minus 5 plus 10 if I didn't collect like terms. All right, so that would be 8. That would give us negative 2 and then 10. Okay, so positive 8, right? And then what else? Just that plus 5, right? Because these two actually went together. Oh, goodness. All right. So again, this answer in red, can we see it now? This answer in red is doable. It would give you the derivative, but we can see that this answer is definitely simplified compared to the red. Okay. This was kind of neat. In this problem, we were able to cross out 4 of those with 4 of those, but you had to factor first. All right. All right, let's try some chain rules and chain rules. Okay, so the good thing is they won't be as long. You just have to see it. You ready? Okay, if you gave up, start again because this won't be as long. Okay. All right, let's go for it. Come on. All right, f of x is equal to sine cubed of 4x. We can't see. Oh, oh. Okay, and it looks smaller too, right? So that's kind of a good thing. Now, keep in mind, the WebAssign is probably better than me. There should actually be 2 sets of parentheses. The first one's optional. Now, the first one WebAssign won't have, or actually the second one. Remember, we can write this as sine. Really, the 4x could definitely go in parentheses. That's the one WebAssign's really good at. And then we could also do it as this cube. And I would definitely take the time to rewrite this cube as this way. Okay. What's the first thing we're going to do? What's the outermost? That exponent. So we're going to roll it down, subtract 1. We're going to roll, okay, so we're starting the derivative. Roll it down, subtract 1. All this stays. But when I rolled it down and subtracted 1, I did it on a quantity. So I have to take the derivative of the quantity. Quantity is sine of 4x, so the derivative of sine is cosine. What about that though? Did I perform that on a quantity? What quantity am I talking about? 4x. Remember, if it's anything besides x, it's a quantity. Right? So now I have to take it times the derivative of the quantity. What's the derivative? The quantity is just 4x. So the derivative is 4. You see that? A lot of kids, maybe I shouldn't even say it, but a lot of kids will answer cosine of 4. You just keep going, okay? It's got to be cosine of 4x and then take its derivative. Okay? They're not short, so don't try to combine it. The only thing here that we could combine, actually this parenthesis here, hang on, let's make sure it looks good. This parenthesis should be here, like its counterpart. Maybe make sure you have that because it's tricky enough. So we rolled it down, subtracted 1, but that's actually pretty important because that whole thing, those parentheses tell me I have to take the derivative of what's inside. So this guy's pretty important because it closes it off and it tells me I have to take the derivative of what's inside. So the only thing I could clean up is maybe those guys. That's it. 12. I would still need those parentheses, or I could write it like this, right? Sine squared of 4x and then cosine of 4x. I'm bad. We probably should have these parentheses here. And that's it. All right, what will this find us? Slope. Remember, now we're trying to see if we can take the derivative of every equation. All right, let's try another trig. Y equals secant to the 4th of 2x squared. Oh, can we see it? Yeah. First thing I would do is rewrite it, right? It's not a waste of time on these. It's really not, because remember, then I use my parentheses and I see that I have a quantity. Because as soon as I perform a derivative on a quantity, I have to take its derivative. So that is not a waste of time. I know this is more efficient, so you'll always see it like that. But when you go to do the derivative, it's a good idea to rewrite it. Okay, what's the first thing we're going to do? Power rule. Yeah, perfect. Right. Roll it down, subtract 1. That exponent is the outermost, so I'm going to roll it down, subtract 1. This parenthesis, make sure I get that in this time. But I did the power rule on a quantity, so I have to take the derivative of the quantity. Now, what's the derivative of secant? This one's kind of weird, isn't it? Secant tangent. So I'm going to write it as secant of 2x and tangent of 2x. But what I took the derivative, oh, sorry, it's actually 2x squared, isn't it? This guy, sorry about that guy. So I perform, now ignore everything else, I perform the derivative of secant on a quantity. So I have to take the derivative of the quantity. I do not have to do it twice because this whole thing is part of the derivative. I took the derivative on this quantity. So I still need, what's the last thing that I'm going to write? 4x. Okay. I don't have to do it twice because that secant tangent is all together. Can we read that? We have to rewrite it anyways because we can multiply the 4s. So 16, we'll go ahead and bring the x to the front. I can rewrite this back as secant cubed, so I don't need those parentheses anymore. And then it is, oh, this is kind of cool. We can write this as secant, and then this is 2x squared. I need to make sure that I get that in there. And tangent of 2x. And I can actually, can't I? And that answer's not too bad, but it's all multiplication and these two are the same. Secant of 2x squared, and this is secant of 2x squared. This is 3 of them, and this is 1 of them. So I can put it together as 4. Yeah, so 16x, secant then to the 4th, and I still have this tangent. Can't put those together. All right, let's do one more trig, change it up just a little. Are we doing okay? Okay, last one is y equals sine of cosine of 5x. And actually, okay, and keep in mind, let me write it like this, that the 5x might not be in parentheses if it's small enough sometimes. And I should look if some books do and some books don't, but kind of it might help to put it in parentheses because that is a quantity. So now what's the first thing we're going to take the derivative of? We don't have any exponents. We're not going to do the power rule. But what's on the outermost? Sine. So the derivative of sine, so let's start. This is our derivative. Derivative of sine is cosine. And I simply do it on whatever's written. But because this is a quantity, I have to take it times the derivative of that quantity. Derivative of cosine is negative sine. So just make sure it's times. So I'm going to put parentheses, negative sine of 5x. And again, these are kind of optional. I'll try to double check, but did I perform it on a quantity? As long as it's not just x, I have to take it times the derivative of the quantity, which is 5. Yeah, and that's it. I could put this negative and this 5 together. So we could do negative 5 and then cosine, this is kind of weird, but cosine of 5x and then sine of 5x. I was not consistent there. I could put these parentheses here. Yeah, and if you want to see what does it look like without any of those parentheses, so you see it, okay. Cosine, these parentheses we have to have, and then sine of 5x, kind of like that. Okay, we finished, good. All right, so give those a try. Remember, so we got, each one can be different. We got rules inside of rules, and we've got that component of simplify. Okay, so try your best on the simplifying. I know some years kids did okay, some years kids were yelling. So, and then I say go yell at your algebra teacher, but you know, it is what it is. Okay, guys, don't panic. Okay. All right, I think we did okay. Keep working, at least keep trying. WebAssign is good about not simplifying. So if you're hung up on the simplifying, even though it's long, you can type it in. Because WebAssign will take 2/4 over what, 1/2. It doesn't matter. So if you're really stuck, type in the part before you even start simplifying. All right, guys. I forgot. Did I record this? Yes.